everybody, this is Dr. Anna, and as I promised, I am working on the review for midterm. So first I'm gonna show you exactly where the time scale is. Remember, the time scale is 10% of your midterm, so you got to know it. The location is right here, so I am under announcement. By the way, I put this up here so you have it there. You have to go all the way down. It's right here, Geologic time scale, and you copy this link and then you bring it up on the internet like I did. So it brings this up right here, and you can, this is what I am gonna attach to the midterm, so it's right there, and you just fill it out. This is how I want it to be filled out. Some people ask me if I will take off points for misspelling. Like if you misspell one or two little letter there, it's not such a big deal, but that's all. I can return here, and this is something you can type in, so, and then you can check if you did it right, so you can even practice the spelling there, so it's kind of cool. So that's the time scale. Remember, it will be attached to the test. You will have to fill it out exactly this one. So let's go through the slideshow, starting with the geologic time. I'm not going to get into it. I'm just going to go through the slides really quick. So this is slide 1. I want you to know a little bit about all of these scientists, and I might ask a question or two. But remember, this is the midterm. So about the people, what did they do? I will ask. Of course, you don't have to know the birth date and time of death and stuff like that. But just know each of them and what did they do, what are they important for. Like Cuvier, you know, he's the one who did the catastrophism, so it's kind of important. And he's the one who founded the vertebrate paleontology. He's the one who found the first fossils. James Hutton, of course, you have to know that he is the father of historical geology, and he come up with the uniformitarianism. It's kind of very important. Of course, without question, you got to know the geologic principles. I mean, there is no question about that. Yeah, these principles are the most important. I'm just looking at what the principles are, but you should know just a little bit about the calendar year and the geologic time. Just a little bit, you know, I might ask a question or so. Remember, at the end of the test, you have the chance to do the extra credit, so you can write as much as you want. It's always good. Remember, you can get a whole grade up, so let's say if you made an 80 and you put a whole lot of extra credit, you can get an A, so it's a good thing, especially if you made 83, like you can go up. You have to know the relative and absolute time scale, and what is relative means. Here are the principles, so this is extremely important that you know the principles, all of them, and you also have to be able to explain which one is what. So if I ask you, please list and characterize the principles, then probably the best way to go about is just to make a little sketch. I think that's the best. So I'm just gonna run through the principles now here. The unconformities, they are very important to understand how much time is missing at the places. And the absolute age, I mean, remember, you got to know Mary Sklodowska, who was she, what did she do, and of course you have to be able to explain what is the radioactive isotope and the types of decay. I asked it before and I might ask it again. You have to understand that the alpha decay is not a helium atom which comes out. It's just a particle which is similar to the helium nucleus. It has 2 protons and 2 neutrons, so it looks like a helium nucleus, but it's definitely not a helium nucleus. And then the beta, of course, which is equal with the electron, because a neutron is losing an electron and becomes proton, so it's important to understand. And you also have to list the gamma decay, even though it doesn't change much, but it's still there. It rearranges the the nucleus of the atom. So that's also a type of decay. And the X-ray is what kills us, really. So these are the decay types. And you also have to understand what is the half-life, of course. And you probably want to be able to draw the half-life curve. Okay, so you know what is the half-life. And you want to be able to draw the half-life curve, of course. Like, it's important when you draw the curve that what this axis means and what this axis means. So label the axis, I should say. It's important. Understand that these isotopes are not only decaying one time, but some of them will decay 9 times before it gets into the stable form. What kind of problems you might have, that's also kind of important, but yeah, that's important. And know something about the fission track dating. These damages are made by of a particle, and you have to etch the sample with hydrofluoric acid for these decay mistakes to come up, otherwise you won't see them. So that's chapter 1. Let's move on to chapter 2, which is the rock fossils and time. And I go up, this come up like I can see actually. So here you got to understand the characteristics of sedimentary rocks, of what are their meanings, of course, but you know, I cannot really ask much about that. But understand what is maturity, understand what the shape of grain means, what does it tell us if you see it in the rocks, and so on. And I might ask a question or two about them. The sedimentary structures, remember I might ask you, please list and characterize the sedimentary structures, and then you kind of have to list it for me. List them for me. The layering, the mud cracks, the cross bedding, ripple marks, graded bedding, trace fossils. So these are the sedimentary structures, and I might ask them, and then you have to come up with it and characterize it. Of course, it's a minimum requirement that you know all the sedimentary rocks, and it goes right here. So I could ask anything about them, you got to know. The facies, it's very important that you understand the lateral relationship. What is intertonguing, what is a sedimentary facies, these are important, and how the different facies comes after each other, like this one right here. See, going from the beach environment, shallow, intermediate, and deep water. What is transgression? You have to be able, remember on the YouTube video I have drawn this, so you got to be able to draw transgression and regression and understand. This is very important. This is going to be a 4 or 5 point drawing, so you got to know either the transgression or the regression. So what is the Walter's law? That's kind of important. So it could be a true, false, or multiple choice question. What is sedimentary cycle? That's also important. And that these are the sedimentary environments. Don't forget, these are, when I talk about sedimentary environments, I'm talking about the siliciclastic long system, which is proof of the large continent, the short system, which is like an island, like oceanic plate boundary, and then the carbonate dominated system, which is related to the tropical climate. So this is like mid-latitude climate, and this is tropics, and this shows you the environment. And then the sea level changes, that's kind of important, so know this slide. It's something you want to know. If I accidentally didn't ask it, you can always write it down, but please just know this. And the short-term sea level changes are related to the gravitational movement between the planets. We're going to go through the details in the Cenozoic, but for now you just know this. And of course you got to know some about the fossils. And yeah, the fossil record, and of course the principle, but that was already one of the principles anyway. So I think that's about it on this one. The formation, here it says what is the formation, so you should know the formation. And I just talked about it yesterday. So this is the smallest mappable rock unit. And you don't really have to worry. I mean, you understand what is the correlation. And what is the index fossils? That's kind of important. It's somewhere here, right here. What is index fossils? I might ask questions about it. Okay, so that's chapter 2. That's a big chapter, so you better get on with it. And this one here is that's chapter 3, the environment. And one important thing about here is the hypsometric curve. I might ask that, so you should know it. And a little bit about the ecology stuff. But I understand that you more likely already kind of know it. It's important to know what is diversity, of course, biogeography. And then these are the climate zones. So these are not the environments, climate zones and environments on the continent. So it's a different thing than the other one was. And these are the ones, I might ask that too. So it's important that you know the different climate zones. And this goes through that one. Understand each climate zone, what kind of diversity, so you get the relationship between the climate and diversity. It's important to understand. So these are all those. And then why would the climate be important? That's kind of understandable that from the fossils we kind of know what kind of climate it was at the time. This is the marine, and you should know these. If I ask you the environments of the marine realm, these are the ones you have to talk about. And that is exactly each kind of important. What is the photic zone? Important. The planktons, of course. And then the necton. You should know what is the necton and what is benthos. Plankton and necton together is pelagic life. I might ask you questions. I asked it before. And here is the benthos. So these are kind of important. Salinity. I want you to understand what is salinity, what is the normal, brackish, which is the less, and the hypersaline, which is the more. The energy level. So the sedimentary environment, so this slide, you understand, these are the continental, transitional, and marine. So these are kind of important. These are the continental environments, right here, glacial, glacial lake, desert, rivers, braided streams. So all this stuff is quite important. I might ask it, and then you have to be able to just characterize it a little bit. And then the marine environment, the organic reefs, the different types of reefs are kind of important. And there is a hidden thing right here, the CCD, which is the carbonate compensation depth. That is the depth below which the calcium carbonate doesn't precipitate anymore. So when you only have quartz-based sediment in the ocean, then you know that you are below the CCD, which is the carbonate compensation depth. Above it, you have limestone forming in the tropics, but below it, even in the tropics, you will not get limestone, so it's kind of important. So that's chapter 3, and now we move on to evolution. Please know these. What is hypothesis, what is law of fact, and what is theory. So it's very important. You cannot use anything, so it has to be in your head now. Exactly what is evolution. Know a little bit about the history, you know, who said what. It's important to know just a little bit about each of them. So we already have kind of, I hope you already have gone through Darwin. What did he do, you know, why he is important, what is natural selection, evidence of evolution. I realize this, it's 100%. You have to know all of it and understand which one is what. You got to know there was people with problems with analogy. You got to understand what is homology and analogy. So please learn it. It's right there. You when it looks similar, but very very different structure. That's analogy. And then we're going through the Gregor Mendel. Just know a little bit. What did he do? How did he come up with the different genes which characterize the inheritance and the law of inheritance? I cannot really ask that much because it's a midterm, only 800 questions, but just know a little bit about it, please. Like the fact that the number of chromosomes is the same for a species but different among species, that's important. You should know the meiosis and the mitosis and the phenotype versus genotype, and the mechanisms. These are important, like here, the micro and macro evolution. So remember, the microevolution is the different mechanisms, and just know a little bit about each, and I have them right here. So I might ask that to please list and characterize. So then you have to say 1 or 2 words about each. These are quite interesting, I think. Why is the sexual selection? The sex is so important in terms of evolution. What is the artificial selection? Somebody said that they didn't know it. This is when we step in. The macroevolution and the steps, so you got to know these guys right here and which one means what. That's quite important. And so that's about it. It's not that difficult then. And then we are to the next chapter, which is the plate tectonics. So it's not going to be that bad, you guys. Probably the time scale is the worst. Understand the faults and what kind of environments they occur. We know that the folding is always convergent, so that's easy. Know what is normal fault. You got to know it a little bit to understand what's going on here. So what is graben and all that good stuff you should know. And then, of course, you got to understand the 3 different plate boundaries, understand the core continental rift and oceanic drift, grabens, again. The examples like the Red Sea, Gulf of Aden, and the Lake Baikal. Here is the Dead Sea Rift, actually. And remember the triple junction, and one of the nicest looking one is the Red Sea, Gulf of Aden, and East African Rift Basins. So right here, that's the East African Rift Basins, Red Sea, and Gulf of Aden. So I might put the question up to match the type of plate boundary to the location. So that's why you got to know example for each. Also, this is different from last semester. You also have to understand what kind of sediments you're going to find in a rift basin. Remember, with a rift basin, when you have a graben, the sediment is coming right from the mountain, so it's never going to be a mature sedimentary environment. And this is the oceanic drift. Understand what is a passive margin, what kind of sediment you're going to have on a passive margin. Usually when you have a passive margin, that's given that it's on a big continent, so you're always going to have quartz sandstone on the passive margin if it's in mid-latitude, and if it's in the tropics, it's going to be carbonate, of course. Ancient examples, you should know the Triassic rift basins, and this just shows you the age of the seafloor. Convergent plate boundary, oceanic, continental, continent. You got to know each. Remember on the drawings now I show you the location of the forearc and the back arc. It's important to know. You have to be able to draw these drawings. It's important, really important. And you also have to understand what kind of sediments you're gonna have in the back arc, what kind of sediments you're gonna have in the forearc basin, and example. So it's very important. So here is the oceanic continental. In the oceanic continental, you got 4 land basin. Okay, so forearc and 4 land. And then the continent examples: Alps, Himalaya. Alps is between Africa and Europe. Himalaya is between India and Asia. And what kind of sedimentary basins are you going to have there? So it's kind of important. Transform plate boundaries, San Andreas fault, and the hotspots, of course. Hotspots is important. Why? And remember, underneath of Yellowstone there is a hotspot, but it has to burn through the continent, so therefore it's going to be extremely felsic and explosive. This shows you all the hotspots. And the Wilson cycle is extremely important. Understand what is the supercontinent cycle. Wilson cycle equals supercontinent cycle. We're going to learn a whole lot about it afterwards, so it's important. What is orogeny, collision? You got to know these words. And here is the subsidence. I might ask you because it's different from last semester. So you should know the subduction, thermal cooling, sediment loading, and thrust loading. And these are the different sedimentary basins. You also have to understand what kind of sediment could you have in them. Okay, so that's about plate tectonics. And the last chapter is the Archaean. How much of the geologic time is the Archaean? Kind of important. You just need to know a teeny tiny bit about the pre-geologic history. You have to know the different types of meteorite. I might ask you that. Of course, you don't have to know this. You don't. Just what kind of meteorites do we have? The ironstone, what's in it, and the chondrites. Important to understand the carbonaceous chondrite because they believe that that might have brought life to Earth. A chondrite. The origin of the crust, that it started about 3.8 billion years ago in Australia. The evidence is the zircon crystal with the 4.2 billion in the core, and the beginning of the geologic history, and that we have Archaean and Proterozoic. Remember, Archaean is older, Proterozoic is the younger. You have to know what is the shield, what is the craton, and yeah, this is really important. So shield, platform, and craton, these are important words. You got to know the Canadian shield, and yeah, these are the old Canadian shield. And the Precambrian rocks, we got to understand that we have Precambrian rocks in Virginia. It's kind of cool. The 2 types of Archaean rocks you should know, and what are the greenstone belts? It's important. Yeah, this is what I was looking for, the comatites. What kind of rocks are they and what do they prove? It's kind of cool. What kind of tectonic environment could the greenstone belt form? That's kind of important. The Archaean plate tectonics, this slide is important that it was faster than it is today because most likely we had higher internal temperature. What kind of atmosphere? This here is very important, the outgassing, and this was the original atmosphere. This is very important. The fact that we had no oxygen, and how do we have the proof for that? That's important. Origin of life, just know a little bit about it. I mean, I won't really ask that much about it, but just a little bit know about it. So that's that. What are the stromatolites? Actually, this slide is pretty important. What is the stromatolite? Because these are the guys who produce the atmosphere we have today. So this is very important to know it. What are stromatolites? Where do they occur? And then the mineral resources. I might ask you, what are the mineral resources of the Precambrian? And then this is the slide you got to know. So that's it. I hope you're gonna get ready for the midterm, and I will see you Wednesday. Study. Bye.